All right, everybody. Today we are moving and we're jumping to chapter 5 in the Just-in-Time book. And so we're looking at angles. Okay, so the first thing we'll define is a unit circle. So the unit circle is a circle of radius 1 that's centered at the origin. Okay, actually, let's do this. All right, so there's our unit circle, and it's a radius 1 and centered at the origin. All right, so then we've got the angle corresponding to an arc length of 1 on the unit circle is called a radian. Okay, so if I've got if I've got an arc going along the edge of this, so if I've got an arc going along the edge of my circle. Okay, this inside angle is the angle that corresponds to that arc. Okay, and so this is called a radian. All right, and a circle is 2 pi radians or 360 degrees. So if I were to take this angle and go all the way around to the other side of the circle, it would be 2 pi radian or 360 degrees. Okay. We can also solve for pi, just pi. We can find out what that is, and that'll be useful. So we know 2 pi is equal to 360 degrees. All right, so then this is equivalent to 1, which is also equivalent to 180 degrees over pi, or pi over 180 degrees. Because pi is equal to 180 degrees. Okay, because that would be half of our circle. All right. So we can use this to convert from radian to degrees and then back. So if we want to convert 27 degrees to radian, we'll use this fact that 1 is equal to 2 pi over 360. So we know, so 27 degrees is equal to 27 times 2 pi over 360. Because this is just 1, so we're not changing anything. All right, and this is equal, we can simplify it some, and we get 3 over 40 times 2 pi. And simplifying it once more, and we get 3 pi over 20. Okay, so that's what 27 degrees is in radians. We can also go the other way. So if we want to convert from radians to degrees, okay, remember I said that 2 pi is equal to 360, and that means that pi itself is just equal to 180 degrees. All right, so if I've got 5 over 6 pi, I can replace this pi with 180. So this is equal to negative 5/6 times 180 degrees, which is equal to negative 150 degrees. Okay. All right, so there's just basic how we convert back and forth. So our unit circle, any coordinate on it can be given by sine and cosine, where cosine is our x value, sine is our y value. Okay, for each angle theta, where COS is the cosine of theta and SIN is the sine of theta. All right, so these functions are periodic since they repeat themselves over a fixed interval. Okay, so if I were to draw it out, okay, let's see, they go from -1 to 1, and then we can say -2 pi pi, negative 3 pi over 2, negative pi over 2, pi over 2, pi, 3 pi over 2, 2 pi. Okay, and I'm going to copy this because we'll have 3 functions that we'll want to do. All right, so our first function, we'll graph cosine first. So cosine of theta, okay, it'll look like this. Let's start. Okay, and it's periodic, so we can see where it repeats itself over the interval. So from 2 pi to 0, and from 0 to positive. I misdrew that. That's what I get for trying to draw it zoomed in. All right, so from negative 2 pi to 0, and from 0 to positive 2 pi is the same basic shape of the graph. Okay, and if I were to draw it out to 4 pi, it'd be the same shape again. Okay, in fact, you could, if these were done by a computer and not by hand, you've got human error. But if they were done by computer, I could take this and just drag it over here, and everything should line up. Okay, that's what it means to repeat over a fixed interval. Every 2 pi, it's going to repeat. Okay, sine is the same way. So I have sine of theta. We're going on this graph. So sine of theta. Okay, so sine of theta should have this basic shape. And again, we can see where it repeats. So negative 2 pi to 0, 0 to 2 pi are going to have the same shape. Okay. All right, and our last one we'll do is tangent. And tangent will be a little different. Still repeats. Okay, but it repeats, it's got a different interval. So it's not 0 to 2 pi. So tangent has these asymptotes. Okay, and then it goes. So tangent repeats, it has an interval of pi. Okay, so it goes from negative pi over 2 to pi over 2, pi over 2 to 3 pi over 2. Okay, and that has a distance of pi, each one of these. Okay, but either way, they're all periodic. So sine and cosine can be considered the ratio of the side of a right triangle. Okay, you might have seen this before. You might remember the term SOHCAHTOA. So if I've got, let's say, an angle theta, let's say they've got the hypotenuse here, the opposite side, and the adjacent side. We take our angle. Hypotenuse is always going to be the side across from the right angle of our triangle. Okay. And then we know the other side will be our adjacent, and then the last one will be our opposite. But we can consider sine, cosine, and tangent in terms of our sides of our triangle. So sine of theta is going to be the opposite over hypotenuse. Cosine of theta is going to be the adjacent over hypotenuse. And tangent of theta is going to be the opposite over adjacent. Okay, and so you might have remembered this as SOHCAHTOA. Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tan, opposite, adjacent. Okay, whatever you need to do to remember this. Okay, and we know, so because of these ratios and how everything's related, if we're given one of these, so like if we're given, for example, sine of theta is equal to 3/5, and then we can use this to find our cosine and tangent. Okay, so I'll go and draw out my right triangle, and I know that this will be my hypotenuse. Let's let this be our angle. So we'll have our adjacent down here and our opposite across here. Okay, so we know that sine of theta is equal to opposite over hypotenuse. And so since we're told that it's equal to 3/5, we know that our opposite is going to be of length 3, our hypotenuse is going to be of length 5. So we're just left with trying to find this adjacent angle. So we can use Pythagorean theorem for that. So we know we've got the adjacent side squared plus 3 squared is equal to 5 squared. Okay, so we've got the adjacent squared is going to be equal to 25, that's 5 squared, minus 9, which is 3 squared, and I've moved it over. Okay, so this is equal to 16. So our adjacent is equal to the square root of 16, which in this case is going to be 4. Okay. Now we've got all three of those. I can easily find cosine. So cosine of theta is going to be the adjacent over hypotenuse. And so for this case, it'll be 4/5. Tangent is going to be the opposite over the adjacent. And so that'll be, in this case, 3/4. All righty. Now, this is kind of a plug. This will be useful when we talk about the double angle formulas in a little bit. All right, so with these, we've got some specialty angles on the unit circle. So our specialty angles are pi/4, pi/6, and pi/3. So we can take a look at these. So we'll do pi/3 and pi/6 first because they're related. So if I take a triangle and all of my sides have length 1, and I cut this down the middle, that gives me my right angle, and this side, or this is half because it's half the length. All right, and then I've got this angle up here is pi/6 or 30 degrees. This angle down here is pi/3 or 60 degrees. Okay, and this is kind of just a trademark of these triangles. And so then we can just say we've got theta over here. And this side would be our opposite of theta. All righty. So what we can do is we've got to figure out the length of this opposite side here. Okay, we can use Pythagorean theorem. And so we've got that the opposite side squared plus 1/2 squared, because we know that this length is 1/2, is equal to 1. Distance here squared, which is just 1. So we can say, okay, well, the opposite squared is equal to 1 minus 1/4, which is 3/4. So the opposite is equal to the square root of 3/4, or root 3 over 2. All right. So this can be translated into our graph, or into our circle. So if I've got I'm just going to do this first quadrant of our circle, but we've got our 1 up here, and we're at 1 down here. So I can take these triangles and put them in for my circle. And so if I've got the 60-degree angle triangle, the ground, so that's 60 degrees. Okay, and I can also have my 30-degree angle. Okay, so for this one, the 30-degree, it's pi over 3, and that has the coordinates root 3 over 2 and 1/2. Up here we've got pi over 6, and that has the coordinates 1/2 root 3 over 2. Okay, remembering that, so we've got cosine is 1/2. For pi over 6, we've got cosine is 1/2. Sine is root 3 over 2. For pi over 3, it switches. All right. And then we've got pi over 4. So pi over 4, we can look at a specialty triangle. We got a right angle, and we've got a 45-degree angle up here. And so that's pi over 4. And so we know that this is of length 1. And we don't know what our sides are, but they're the same, whatever they are. Because that's a trait of a 45, 90 triangle. All right, so with this triangle, okay, we don't know what our sides are, but we know that this s squared plus side squared is equal to 1 squared. So we can add these, and so we get 2s squared is equal to 1. So s squared is equal to 1/2. And so s is equal to the square root of 1 over 2, or 1 over the square root of 2, and we can rationalize it. And we get root 2 over 2. So for our, let's do this one in blue. If we add this onto our quadrant up here, okay, this angle is 45 degrees. So that makes this pi over 4. And this has coordinates root 2 over 2, root 2 over 2. Okay. And so you might be saying, oh yeah, the unit circle. And so it's got each of the angles that goes around. So we can use these. This is the first quadrant. The other quadrants mirror this one. We just have some changes of signs. So we can fill those in. Got a nice circle. All right, so then I've got, cut you this way. Okay, let me adjust just a little here. That's good enough. But so our first quadrant will have both be positive. Second, your cosine will be negative, your sine will be positive. The third quadrant will both be negative. Fourth quadrant, cosine will be positive, sine will be negative. So we've got quadrants 1, 2, 3, 4. Okay, one way to remember that is that if you start in the first one and draw a C, okay, your numbers follow around the C. But you need to make sure you know these signs. All right, so we can fill it in. So in our first quadrant, we've got pi over 6, which is root 3 over 2, 1/2. We've got pi over 4, which is root 2 over 2, root 2 over 2. And then we've got pi over 3, which is 1/2 root 3 over 2. Then we've got pi over 2, which has the point 0, 1. We've got, in our second quadrant, all of our cosines, or our x values, would be negative. So for 2 pi over 3, we've got negative 1/2 root 3 over 2. For 3 pi over 4, we've got negative root 2 over 2, root 2 over 2. For 5 pi over 6, we've got negative root 3 over 2, 1/2. Okay, for pi, we've got the point negative 1, 0. All right, so now we're moving into quadrant 3, where both our cosine and our sine will be negative. So we've got 7 pi over 6 is negative root 3 over 2, negative 1/2. We've got 5 pi over 4, which will be negative root 2 over 2, negative root 2 over 2. We've got 4 pi over 3, which is negative 1/2, negative root 3 over 2. And then we've got 3 pi over 2, which is the point 0, negative 1. All right, so now we're moving into our last quadrant, where our cosine will be positive and our sine will be negative. So we've got 5 pi over 3, which will be 1/2, negative 3 over 2. 7 pi over 4, which is root 2 over 2, negative root 2 over 2. And then we've got 11 pi over 6, which would be root 3 over 2, negative 1/2. All right, and then lastly, we've got 2 pi. So this axis here, the x-axis, that is both 0 and 2 pi, depending on how you look at it. Either way, it's 1, 0 as our point. All right. So you should be able to, looking at it, see how we take these first three, and then they just mirror along, or in each of the quadrants. Okay. So there's our unit circle. And then lastly, today we'll look at some other trig functions. So we can find or look at other trig functions using ratios between sine and cosine. So tangent will be sine divided by cosine. Cotangent will be cosine divided by sine. Secant will be 1 over cosine. Cosecant will be 1 over sine. Okay. So we can look at, we can do an example. So if we're given 1, so let's say we're given sine of theta is equal to 3/5. Okay, and we're looking at it specifically on this interval from we're looking at it on this interval from pi over 2 to pi. So that would be this interval, the quadrant 2, okay, which means that our cosine is going to be negative and our sine will be positive. Okay, which will come in important in just a minute. So we're given sine, so we need to find our other, we'll need to find cosine first. So we know that we'll take this to be angle theta, and there's our right angle. And since we have sine, we know that the opposite is 3, the hypotenuse is 5, and we're looking for this adjacent angle right here. So 5 squared minus 3 squared is equal to a squared. So we've got 25 minus 9 is equal to a squared. So that's 16 is equal to a squared. So positive or negative 4 is equal to a. Now, if I take positive 4, so let's say we take positive 4, then cosine is going to be positive 4/5. But we need it to be negative, so we'll take a negative right here. So we'll take the negative 4 because cosine of theta is negative in quadrant 2. Okay, that's where it's important to pay attention to those signs so you can get the numbers, because if we didn't make that negative, then it would make the rest of the answers wrong that use that number. All right, so now we just need to we use our relations and find the rest of our other trig functions. Okay, so we know cosine of theta is negative 5/4. So that means tangent of theta, which is sine of theta over cosine of theta, is 3/5 over negative 4/5. Division of fractions, we get negative 3/4. Okay, cotangent of theta is cosine of theta over sine of theta, which would be negative 4/5 over 3/5, which is negative 4/3. And so then we've got secant of theta. 1 over cosine of theta, which is 1 over negative 4/5, which will be negative 5/4. Then lastly, we've got cosecant of theta, which is 1 over sine of theta, 1 over 3/5, which is 5/3. Okay. So there's our other trig functions. All right, so we'll be working on the learning activity and talking about this section in class Monday and Tuesday. All righty. And so if you've got questions, you can email me or ask me then.